Hello everyone, my name is Shen, and in this video I will talk about how to create a refrigerator management agent. So in the last video I have created a refrigerator LLM chat system, and now we will convert this LLM model to become an agent. So why do we need to convert the LLM model to become an agent? Since in the last video I have already shown some example by using the LLM model to help me to solve the tasks, to call the tools, to change the database. Yeah, it's already perfect. So why do we still need the agents? It's because by using the LLM model, the LLM model can only solve some simple tasks. And if the task is become more complex, the LLM models will be confused by the instruction given by user, and maybe we'll skip some sentences. And the LLM model don't have the memory, so every time if we call the conversations, we need to conclude the summary of the last message we have said to the LLM model. So this issue can be solved by using an agent. This is because agents have the technique which is called React and COT. COT means chain of thoughts. So the agents will split out the complex tasks given by a user into a chain of the list of the instructions. So here is the example, like the inputs from the user will split into several steps, so the AI agents can do the steps one by one. It will not miss out anything. And in the React means reason and acting. The AI model will keep looping and thinking on what do the user wants, what is the tools the agent needed to call, what do the user really wants, and is the response meet up the requirements of the user. So the final answers will become more likely to be accepted by the user. Okay, so let me briefly explain about what have I done in the project one. So here is architecture. First, the user will send inputs, and then the LLM model will understand the request and to think about whether it needs to call the function or change the database, and then the result will be given back. Then the LLM will generate out a more understandable response to the user. And here is the project tool. And first, the user will send out a message, and then the agents will load the chat memory. After that, it will go to think what does the user wants, and then it will go cycle tools. Maybe it will change the database or go to the other two functions. So these two functions is newly done inside this project. The first function is to analyze the receipt, and the second one is to give some recommendations on the recipe. So that's the user, for example, if the user go out for a shopping and then after it gets the receipt from the shopping marts, the user can simply photo the receipts and then send into the database and ask the AI agents to just analysis of the food items and then to grab out the items name, the quantity, and then straight into the database. For the recipe is the AI agents will read on the database of the recipe and give out some recommendations based on the fridge items by the user. So the user will know by having the fish items, what can the user cook. After after the tools have been done, then is you update the agent's memory and then generate out a final response to the user. Okay. The refrigerator management agents is an AI agent system that helps users manage refrigerator inventory, analyzes the receipt, tracks food expiry, and recommends recipes to reduce food waste. The reason I'm doing these agents is because sometimes the people will forget what have they bought and just put inside the fridge, and after a few days then he'll forget on the items that he buy, and after days going then the food becomes expired already, then need to be thrown away. Yeah, so by using this agent, it can help us to reduce the food waste. And here for the recipe database, I'm using the database from the Crispin Gary. So here's his database for the baking JSON, budget food, house food recipe, inspiration food recipes, and here is all. And this is the keys and the values, got name, got description, ingredients, and the steps to do the recipe. And another dataset I've used is the food receipt database. This first receipt database is collected by is generated out by me. So I've only put the 4 food receipt images into this database. Yeah, just for the demo purposes. Okay, so let us start the so let me start to explain what have I done in this project. So first is a setup. Yeah, I skip on this because I've done in the project one, which the LLM model, yeah, I've done. So I skip on this. And the setup verification, so whether retry on the API. So put my API inside the project and create a local database for the refrigerators and add some value inside the refrigerators. Here's to connect my notebook to the receipt image datasets. So here's the verification. Can I open the image? And to connect my notebook to the recipe datasets. And here is shown the top 5 of the recipe. So here's the info of the recipe database. And the database function is also same like I have done in the project one. Yeah, got one new added function which is called the update per query. So this function is basically saying that if the user say wrong on the quantity of the food items, just like the user say that I have bought 2 liters, and just help me add inside the database, but actually there is 5. So the AI agents can call these functions just update the quantity only. Okay, so this function has already explained in the last video. So here's the verification. Can I call the database functions? Yes, I can. So the rounding function is also same been done in the last projects. Define confirmation functions. This is also a new function I've done in this project, which is to define a confirm query. It's a security features I've added in because sometimes AI agents, because in this project, my AI agents can simply access into the database. So then I put this confirmation query. So every time the AI agents wants to add items inside the database or delete or update the database, it needs to ask again the user, does this request really given out by the user? And it is not just simply sent out by the AI agents. So that's the AI agent's response. So this request is not just basically called by the AI agents. So prevents the AI agents mistakenly update the database. So here's the receive functions. The first receive function is to list out the receive image. So let the user know what is the receive name. So the next one is to let the user know, to let the AI agents analysis the receipt. So that the AI agent can get the item name and the quantity of the inside the receipt. And here is the recipe functions. First one is to recommend which recipe can be cooked by the user based on the fridge items, and the recipe function is to get the ingredients and the cooking steps. Okay, now I will define my agents. It's the example of the few shots prompting, and I will use LangGraph to define my agents. LangGraph is to make my agents to become more, to have the functions on memories things. So in a LangGraph, there is a functions, there is features called node. So node is things that can help the AI agents to memorize the current states and what should the AI agents do and the next steps. And it's just the states. And here's the class of the refrigerator. I will define the base concepts here. So here's the keys that the refrigerator needs to always holding the value. And here's the system prompts, like the base concept of the refrigerator AI agents. Like you are a fridge boss, and then what tools you can access, like the important things for the AI agents, and the receive functions, how to do, and recipes, few shots. Example one is the user wants to list out the refrigerator item. Example two is the user wants to add some items inside the database. Example three is to let the user remove the item from the database. The last example is the user wants to know what can he cook based on his refrigerator items and give some cooking steps to the user. Okay, so I define the human nodes for the messages will store in here and maybe exit human nodes. If the human wants to exit the chatbots, then it will exit and to reach. In this project, I didn't use the LangChain tool node to define the tool bridge because my Gemini 3.1 flashlights it has already used up no, the Gemini 3.1 didn't have the functions to call the LangChain tool node. So we need to define ourselves the tool bridge so that the AI agents to call the tool. Okay, so here's the Gemini tools so that the AI agents know the requirements to call the tools. And then here's the list, is the node, the chatbot with tools node. Just to handle the confirmation function, first interaction. If the user is first time to speak with the AI agents, we will send out the welcome message. And then is to convert the messages to become Gemini formats. So is to handle if got several tools are called, so that we will call the tools one by one. If no tools, then we will return a AI generated message. Is the function to execute the Gemini tool. If tools call is not inside the list, the tool list, then you will return the unknown tools. If got, then it will help to call the tools. And here is to build the graph of the AI agents. So we have defined two nodes just now, and the edge to connect the nodes is to connect start to the chatbots to the human, and then if the humans want to exit, then it will go exit. If no, it will go back to the chatbots and compile all together and roll out an image. Here start chatbots to human, humans to chatbots, and then go ends. Okay, here I'll start to do the testing to show some example. Okay, so like user and okay, I will explain IP. So every time the chatbots will start the conversation first, send out the welcome message, and user say hi, and you explain on what can he do. So I think it's this means show me my fridge items. Then you start to call the tools to execute query. And then here is the response. So go on, item name, quantity, list to the user. So I have bought 2 broccoli today at 10. Then the AI agents will call the rounding functions. So search on the Google, today is what day? Today is July 22, and then see a search on the broccoli can store inside the refrigerator on how many days? You can store 3 to 5 days. And what is the category of broccoli? It's vegetable. And so that is everything is get already. You ask again, is the user really wants to add in the broccoli inside the database? Yes. Okay, done. Oh, the user say that is wrong. The quantity is 6. Okay, you ask again the confirmation query. The users say yes. Okay, the agent has updated query. So now let's delete the database. Yes. Okay. And here's the food receipt functions. So list out got what data is got what images is inside the database and analysis. What is the food item inside the receipt? Okay, then into the fridge. Okay, so here confirm query and yes, insert query, then yes, and show again what's the items inside the fridge. Yeah, so here's the result. Okay, cool. So you recommend some recipe. So got 100% ingredient available. So here's the available percents for missing what's fruits. Okay, so can I cook fruity for them? No, you are missing these things. Can I cook slow cooking yogurts? Give me the recipe. Okay, can cook. So it can. So you will return out the ingredients needed, the instructions, and is there anything else? No, goodbye. Okay, so that's all for the agents. It has the functions to call the database, operates the database, to analysis the food receipts, and the last one is to recommend the recipe to the user. So that's all for my refrigerator management agents. Okay, thank you.